use the where, just like select from where and use the where on those columns that not aggregate, just the normal columns from the table, just like previously. And for the having, you can only use having with the aggregation part. So where cannot be used with the aggregation part. So you see this the aggregation part, and if you see. If you're doing something like this, it should not allow you to do it. Oh, yep. But this, if you provide this where statement on the department ID, is no difference between the examples that we met in yesterday. But just if you want to use, have some condition on the aggregation part, the max or count, you have to use the having with it. Can you not use the where with the aggregation, with the aggregations? Okay, guys, let's resume our session. So I want to clarify a little bit that for the group by that um, the where just cannot use with the aggregation part, aggregations. So you can just use the wheres normally as previously that on those rows atoms like the department ID or if you select any other columns, but it's not reasonable to select other columns because you have grouped them together. So if other columns have like those multiple values, then it's not reasonable to select those multiple columns in the statement. But let's say that you have this unique attributes, common attributes among those employees like department ID, and you can use the where clause on this uh, table columns, just like previously. But for this aggregation parts, you can only use the having with. You cannot use the where, like where max salary larger than 13. You cannot do that. You can only use the having with the aggregations. You cannot use where with the aggregations. So this is the difference between the where and the having. And yep. And uh, so and also for maybe left and right join. So previously I was like misunderstand something like maybe kind of misleading that you see if we have 1, 2, 3 departments in the maybe do not modify it, it will harm the other examples I gave. So if you have a department with ID 1, when you use the right join, still will consider the departments table in the right position. And when you use the right join, you still like you do exam like every rows in the table A. Like if there is a mat, it will be joined together and search for the next row. There is another mat condition, so it got joined together. And also it will exam for like try to see if there is a match or not. If not, just a field with null value is still the same rules. But you see for those 2 and 3, those should be get rid of because you only exam like if there is any department 1 in the left table, if there is any department 4 in the left table, and if there is, join them. If they're not, just leave the uh, leave the null values. And this will be the same, like is there 1 in the table? Uh, if you use the left join, it's like maintain all the things in the left table. And if there is a match, you will join them together. And if there is multiple match, like if there are one, there is like several two, like just for example, and then if you use the left join, you will join like 2 with 2, and also this 2 with this 2, like join all the mating rows. But if there, if you see this 4 is uniquely in the B, so there's no 4 in the table A, so it will be get rid of. The rules is still the same, like maintain um, all the rows in the table A and try to join everything that's made the condition in the table B and things like that. So let me modify it back. Okay. So okay, this is the join and group by. So for the next topic will be the transaction. So does anyone know what is a transaction? Mm, So yeah, the transaction is a series of queries. Good. So it should be like a series of queries. And also yesterday when we talk about the database, you mentioned about the ACID principles, right? So those are the properties of the transaction. So today we will talk about what is ACID stands for. And also for a transaction, it's more like you will do something like begin your transaction, and then later you can do a bunch of queries, maybe select or maybe insert or delete. You will do a lot of things like that. And after you finish all of the things, maybe you have a bunch of other queries, you just use commit to commit your all the changes to the database. So this is called a transaction. You see, it is composed by a lot of queries, and then you commit all of them. This is called a transaction. And let me further introduce what is ACID. So we have briefly discussed about it yesterday. That right, the uh, A stand for atomic. So the atomic means all of bunch of queries will be treated as one entity. So that means if they if the transaction success, then all of them should be success. And if any of them failed, then you should roll back all the changes. So this is called atomic. So those bunch of queries will be treated as one entity. They will successful. There will be success. Um, all let me think how to say that. Like um, all of them should be success, or all of them should be failed. Just treat as one thing. So this is atomic. And the next thing is called consistency. The C stands for consistency. Consistency. So what does consistency means? This consistency is you will also see one consistency in the cap theorem, but these two consistency have different meanings. So this consistency means, but like for the isolation level, uncommit read mm, will violate this consistency. But most of the database engines, this default default isolation level will be higher than the uncommit rate, uncommitted rate. So like rate uncommitted. So the consistency here means the stage of the database will move from one valid stage into another valid stage, that all of the intermediate changes should not be seen by other users. So for example, when you begin your transaction and insert some data or delete some data in your transaction, then at this moment, other users should not see the changes in the database. They can only see the stage that's before you begin your transaction and after you commit your changes. So in this manner, the data in the database should only move like from the stage that you begin your transaction, and after see the stage after you commit all the changes, all those intermediate stage like the insertion, deletion before you commit it, all those modification before you commit it, it should not be seen. So this consistency means move from one database stage, move from one valid stage to another valid stage. All the uncommitted changes should not be seen in the database. So this is consistency. And isolation level, I stands for isolation level. So this is like the level of the data integrity that you want to set. Like what's how much you care about the data integrity of your data. So by setting the isolation level to be higher and higher, then your data will be more like trustable, and but it will also slow down the performance. Like for the serializable isolation level, you will add lock when you start the transaction on some of the rows in the tables. And of course, because you lock up the table, part of the table, then other transaction cannot work on this part. So you secure your data integrity, but you slow down the performance. You're blocking other transactions from working on the same rows. Um, and the last word D stands for durability. So durability, I guess. So what does this stand for? That it means you store all the data in your disk, but not just in the memory. So in this way, you can make your data to be durable. This data will not be vanished if your system goes down. It just always store in the disk and be persist in the disk. But if suppose you just store data in the memory, then maybe when you restart your database, then all the data is gone, right? So this D stands for durability. And let me further give you some detailed explanations for the 4 isolation levels. So there are 4 isolation levels called read uncommitted, and read committed, also repeatable read, also serializable. Serializable. Yep, these are the 4 isolation levels. So what does read uncommitted level means? That is, if you set your database to be read uncommitted isolation level, then other transaction can see the intermediate changes. So actually, this isolation level will violate the consistency, right? Because if you allow the other transactions to read on the uncommitted data, then that means those intermediate stage can be seen. So it violates the consistency property. But some of the database, they just provides you this isolation level. But this depends on the implementation of different database engine. So maybe the uncommitted data is called dirty data, because if some of the query failed, it will roll back all the changes. So those changes are still not be committed. They are dirty. They have possibility to be rolled back. So if other users are working on those dirty data, then there is a high possibility that those data will be rolled back and all your work based on those dirty data are become invalid. So most of the database do not provide this read uncommitted isolation level, but some database engine, they provide you this isolation level, like give you the choice to rate the dirty data, like those before you commit your data, those changes can be seen in the database. So this is called read uncommitted. And there is a problem called the dirty read, because the uncommitted data is called like the dirty data, right? Before you commit it, it is called dirty data. And there's a problem called dirty read. So if you other transactions read those uncommitted data, is called the dirty read. And there, if you just as I said before, if you work on those dirty data, other user the transaction failed and roll back those changes, then your further work on those data is become invalid. And to resolve this dirty rate problem. So those are some problems in the read on commit. To resolve it, you should use set the isolation level further to rate committed. And this is also most the default isolation level of most of the database searching engines. And also remember for MySQL database, their default isolation level should be repeatable read. But let me first explain what is read committed. So read committed means you can only read the data that other transaction has committed. So this will follow the idea of the consistency, right? So those intermediate step, those dirty data cannot be read until you committed to make it not to be the dirty data, and then other transaction can read the data. So the data stage will move from the stage before you begin your transaction to after you commit the changes. So this will follow the consistency from the read committed level. And this can resolve the dirty read problem. So the read committed do not have the dirty read problem because you do not have access to those data before the other transaction commits their changes. So read committed resolve the dirty read, but it still have some problem called unrepeatable read. Unrepeatable read. So what does unrepeatable read means? That is, although every time you read the data, those data are not dirty, your other transaction already committed. But imagine a scenario that you have a transaction A trying to select multiple rows to generate a report. And also there's a timeline like this. And like for example, the transaction A tried to generate a report of like each person have how many items. So it suggests that first you select the person A, and after some times you select like how many items that person B have. So you are trying to conduct this two statement. So suppose there are only 10 items in total, and first those 10 items are belongs to person A, and later it should belongs to some transaction change the data, move the 10 items from person A to person B. But actually there is still like totally 10 items. This is not changes. There is no more items being created. So suppose there is a transaction B, like modified when you select first, you select like check how many items that person A have. You will find that person A have 10 items, right? And now the transaction B move the 10 items from person A to person B. So it's like this is a timeline. So in between those two select statements is your transaction B commit some changes like delete the item from person A and insert the data to person B. So after this, when in your A transaction, when you conduct the second select statement, because this has already been committed, right? Committed. So you have the access to the changes data. So when you select from person B, you also find 10 items. So you generate the report saying that, oh, person A have 10 items and also person B have 10 items. So now in your report, you have totally 20 items. So actually this is not what we want. And to resolve this problem, we have to set the isolation level to be repeatable rate. So what does repeatable rate is more like when you start your transaction A, it will create similar things like a snapshot. It will take a snapshot of the current database, and then it will generate the reports based on the snapshot that you created. So that means even though your transaction B have committed the changes, but in my transaction A, I won't see those changes. I only read the data at the time when I begin my transaction. It's like I only read the data from the snapshot. So in this case, if you are using the oh, sorry. So in here, if you set the isolation level to repeatable rate, I will only read when I conduct the second select statement. I will only read it from the snapshot that are created when I begin my transaction. So those changes will not be seen. I will still generate a report like person A have 10 items and person B have 0 items. So this is the repeatable rate. You see, I repeatably read on the snapshot, but in order to generate the report. But if you generate the report, if you begin your transaction after this commit, absolutely you will see the changes. Like now person A have 0 items and person B have 10 items. But when you set the isolation level to be repeatable rate, this is what result you want, right? You do not want this thing happen. Right? You do not want your report to suggest there is 20 items. This is completely wrong. But using this, maybe your report is not the most up to date, but at least at some moment is correct. So at least this report should be correct when you begin your transaction. So if you think this transaction, this report is out of date, maybe you just begin the transaction and generate the report again, but not use this unrepeatable rate isolation level to generate your reports. If you have a long time running transaction, then if other transaction just commit their changes and you do not use repeatable rate, then your report will be completely useless, right? Those because you read is unrepeatable. You just read all the changes that's made during your transaction. So this is called unrepeatable read. And also let me think. There's also another thing called phantom rate. So phantom rate is something like phantom rate. So you see, maybe I should not use the insert. It's more like an update statement. So you update the person A from 10 to 0 and update person B item from 0 to 10. It's more like an update statement. So the phantom rate will be occurred in insertion or deletion. But this deletion, I should include it, wrap it with parentheses, because some of the database, if you set the isolation level to be repeatable rate, they do not have phantom rate problem on deletion. They only have phantom rate on insertion. So let me first introduce what is phantom rate. So phantom rate is that when you are like in the transaction A, you are doing some select statement, right? And this when you're trying to select something that should not be in your, like when you begin your transaction, there is no person C in your when you begin your transaction A, there is no person C, but like there's no person C, but in the transaction B, between your transaction, the transaction B like insert new records of person C, and when you select it, you can still see the person C. So, but this person C should not be seen. This will be called a phantom rate. Like this is a phantom rows that should not be seen in the transaction A, because this person C is inserted in between of your transaction. Maybe I should. So remember that all of that phantom rate and unrepeatable rate also occurred in the rate uncommitted level. Like the highest level will only resolve those problems, but not to say that those lower level do not have phantom rate or unrepeatable rate, because you see, you also you even read the dirty data, so absolutely you will still have the unrepeatable rate. Like every time when you have a long-term transaction in your rate uncommitted level, you will have all the three problem, like unrepeatable rate. Also, you should also have the phantom rate. Like this doesn't mean that the lower level don't have those problems. It's just it's kind of obvious that if you even read the dirty data, then absolutely you cannot have repeatable rate, and also you will have phantom rate. Like you will rate those newly inserted rows. So in the repeatable rate, although you resolve the unrepeatable rate problem, like because you create some kind of snapshot and read from the snapshots to generate report or something like that, you can repeatable rate the same rows. But like for example, if you have the repeatable rate, just means for the same rows you can repeatable rate it. Like for now we have person B now is 0, and when you select it again, you should still have person A with 10 and person B with 0. But for the unrepeatable rate, like for the same rows, when you rate it, you might get different results. Like here, when you rate it again, you should get something like this. This is what this is what seem like in your database. So this is called unrepeatable rate. It's more like say for the same rows, but like for the insert for the phantom rate, your repeatable rate isolation level still have the phantom rate problem. So that is occurred when you insert something into your between your transaction A. Like your transaction A, when between this, when you begin your transaction A and in between your transaction, another transaction, like insert or delete some rows, and when you select it again, just like the example I give, like for example here, I insert person C and committed. So for the repeatable rate, actually you should not see the person C, right? Because this person C insert after you begin your transaction. So, but the phantom rate is like when you select like person C, you will see the result. So this is a problem that called phantom rate. And if you want to resolve this phantom rate problem, you should set your isolation level to serializable. And this serializable will add lock, like the row lock and the the row lock is, I kind of forgot the terminology. Like there is a lock that will even lock the like the between this like the interval between these two rows. Like it will not allow you to insert anything between these two rows, and also add lock on each rows does not allow you to change it. This is isolation level. And with these things, like because you provide the lock, then that means other transaction can not insert anything when you begin your transaction. So this will resolve the phantom rate. So if you set isolation level to be serializable, then there is no phantom rate or any unrepeatable rate or dirty rate problem. But repeatable rate still have the phantom rate problem. So let me give you the exact explanation. Let me explain like the mechanism, how does MySQL achieve the repeatable rate, so you will know that why it still have the phantom rate problem. Like how, let's see how it created snapshot. So actually it not actually create a snapshot of the whole database. It's too cost. It costs too much. It's too expensive. So the reason of the mechanism of the of how it creating the snapshots. So the reason, that is the reason why we still have phantom rate in the repeatable rate, because if you actually you if you indeed create a snapshot, then there should not be phantom rate problem, right? Because if you indeed create a snapshot, whatever you insert into the database, we should just not see it. So why we can see the this is because the mechanism of how we implement our repeatable rate isolation level. So when you create your table, like in MySQL, for example, you have a employee table, maybe HR the employee, and you have something like ID or first name, those columns. And, there will be, besides of those columns that created by you, you still have some implicit columns, those hidden columns called provided by the database. Those are like row ID for retrieving if rows, or you have a transaction ID, and also you have a rollback pointer. So let me introduce what are the usage of those things, those uh, those hidden columns. So the row ID is like to identify from different rows, but the repeatable rate, the magic happens in this transaction ID and the rollback pointers. Like every time when you try to begin your transaction and make changes to this rows, like you update or you insert some data into this rows, you will modify the transaction ID to your own ID. Like every time when you start a transaction, you will be assigned a unique transaction ID, maybe uniquely increasing transaction ID. Like for example, this A maybe have a transaction ID of 3, and when you try to modify it, when you transaction A try to modify it on some rows will be modified to transaction ID 3. That is the ID of your transaction. And also you will have a rollback pointer. This pointer will point to the old data. So it's like this is the new data that's inserted by the transaction A. And then where does the old data goes? That the old data does not get deleted right away. It actually stored in other place, and you will use a pointer to point to the old data. So, and also this old data will contains the whole rows, like all the ID of first name or something like that. Also, it should also have the transaction ID of the previous transaction. Like maybe the previously the transaction 2 make changes to this row. So this transaction ID is 2, things like that. Like all the records before you modify it. So this is the also it should has a robot pointer, maybe point to next the previous one. So this is the transaction ID and rollback pointer. And every time when you started your transaction, you will have a view list, like your transaction A will have a view list. That this view list will contains the transaction ID that's maybe smaller than you or is based on your mechanism, but in this case, it just contain all the transaction ID that happens before you, so commit before you. So, for example, if there is a transaction 1 and transaction 2 have already committed um, before you start your transaction, then in your viewing list, you will have those transaction ID. That means those transaction has already been committed before you start your transaction. So when you try to select data, you will check the transaction ID. So for example, if there is a transaction ID called 4, maybe this is from the transaction B. So transaction B have an ID of 4, and it updates some rows with inside this transaction B, and then it will update all the records and also update the transaction ID rows with the transaction ID columns with ID of 4. So when you try to select this rows in your transaction A, you will find that this transaction ID is not in your viewing list. So you will know this transaction is committed after you begin your transaction. So that means this data should not be seen by you because you only want to you are now want to create something like a snapshot. You only want to read the data when you begin your transaction, right? In order to achieve the repeatable rate. So in this case, this transaction commits after you, not in your viewing list. You should not read it. Where you can read the data is that you go to the rollback pointer. Like this rollback pointer will have a not new data, just the pointer. So you have a rollback pointer to point to the old records. Like maybe this records have uh, those those information and also have a transaction ID of 2. So that means you are finding from this rollback pointer, you're finding the data that you want, you're trying to search for. So this data with transaction ID 2 means these changes are made by transaction 2, transaction with transaction ID 2. This is in your view list. So you know this data is the data that when I begin my transaction. So you will read it. So in with this mechanism, we can achieve the repeatable rate, right? For the same data and for the same rows, you will always read the. But the phantom rate is like when other transaction insert some rows, and for example, the transaction B insert some rows. This rows is the person C. Insert a new rows. This is a new person, like the new person C, and you should have the transaction ID of 4. Although this 4 now absolutely when you select it, you cannot see in your transaction A, you select it, you cannot see it because it's not in your viewing list. But there is the risk that because actually this columns is in your this rows is in your table, right? In your transaction A, although you cannot see it, you can try to update on it. So after you update on it, you will modify the transaction ID to your own transaction ID. And then when you select it again, you can see this rows. So this will result in a phantom rate problem. So you see, this person C is inserted by the transaction B, and this is something that not should be in your snapshot. I see the snapshot. I should double quote it because actually we are not actually creating a snapshot. We're just doing something similar to snapshot because creating a snapshot is too expensive. And for now, when it first get inserted, you're not seeing it. When you try to select, maybe select person C, you cannot see it because this is not in your view list. But you in the MySQL, you can use update to update the records for this rows. But this rows should suppose not be seen by you, but actually you can update on it. And when you update on it, you modify the transaction ID to be yourself. And maybe this will be pointer to the old data, like transaction ID for things like that. But with this behavior, like you update it on it, and then when you select it again, you will read, because this is your own transaction ID. Absolutely, you can read it, and then you will read the phantom rows. This phantom is just something should not exist. So this is called a phantom rate, and this is why the repeatable rate still have the phantom rate problem, and also why I use the parentheses to like quote this one is because like when you use the when other transaction delete on this, maybe delete the person B, and why sometimes this not cause phantom rate is because maybe this let me see. For example, if we have another person B that's previous commit by transaction 2, so it's in your reading list, you can read it, right? And when you read between your transaction, the transaction B deleted. So maybe deleted transaction 4, and now it should be all null value. And there's a pointer point back to the old data. So why we not have phantom rate problem is that when you try to update this thing, you should not be able to update it because the database suggests that it's a null value. So you failed to update this. You will fail to update this rows, and then because you fail to update it, then the transaction ID should still be 4. And when you try to search this row, you will read it from the rollback pointer, like read the old data, the transaction ID with 4. So transaction ID with 2, it will from the rollback pointer, it will read the old data. So sometimes in the MySQL database, at least the deletion won't cause the phantom rate, but maybe in some different implementation, different database engine, they have different implementation for the repeatable rate. So the deletion maybe still have the phantom rate problem. That is when other transaction deletes your rows, when you select it again, you cannot find the data. Then that means this data gone. This data bus should not gone because this data exists when you begin your transaction. So deletion in some of the database engine also have the problem of phantom rate. So this is like the mechanism of repeatable rate in MySQL database, and also some problems that different escalation level have. Any questions related to this part? Actually, you can, but in my mic, I do not have a MySQL installed. But you can try to install a MySQL database, and just in the console, in the like terminal, in the command line, you can just use 2 terminal window and open 2 transactions in each of the window, and you can try to begin a transaction, and you can just create some dummy table and begin a transaction in one window, stimulate the transaction A, and you can see that you set your isolation level to be repeatable rate, and then you try to select some rows, and in another table that the transaction B, you can try to insert some records. You can see in your transaction A, maybe when you first selected, absolutely you will not see the newly inserted data, and when you try to update on it and select it again, you will see the changes in the that made by the transaction B. So this is called phantom rate. You can try to do that, but generally, if you just if you do not have interest to try those experiments, you can just remember that what problems each isolation have, like rate uncommitted have all the three problems, and the rate committed will have the uncomputable rate and unrepeatable rate and phantom rate, and repeatable rate isolation level only have the phantom rate problem, and serializable have no problem. And also should be remember the definition for those problems, like the dirty rate is just read the dirty data, and unrepeatable rate is that in one transaction, when you try to select again, maybe on the same rows, you will get different data. So this will be called unrepeatable rate. And for the phantom rate, it's like you will select some rows that should not be exist here. Like when you insert some rows uh, between your, after you begin your transaction, other transaction insert some rows. This row should not be seen by your transaction, but you read it. So this is called phantom rate. You causing by some insertion or deletion, like maybe some rows that should exist in your transaction, but other transaction deleted and commit. And when you select it again, you cannot select, you cannot see that rows. Then that means this is also called a phantom rate. So those are the problems in the full isolation level. And by setting the isolation level is kind of one way to tune your database performance. Like if you database perform, if you do not care about the data integrity, you can just set the isolation level to lower level, like read committed or something like that, and it can speed up the performance of your database. But if you are caring about the data integrity, like you want to resolve all the phantom rate, repeatable, unrepeatable rate, you can just set the isolation level to be serializable, and this will add lock to your database, but it will slow down your performance. So it's kind of a trade-off, like how you want to do with your database. So yeah, I think that's all for the ACID and the mechanism of the repeatable rate. So is there any questions related to this part? Like anything unclear? Mm, okay, so if no questions, let me introduce a very last thing that called lost update. So this lost update is more like something we see in Java part, like the race condition. So lost update means you have a transaction A and also you have a transaction B, right? And maybe your transaction A, it rate some value, like maybe rate person A have 10 items, and also at the same time, the transaction B select to rate there is 10 items for person A, and when you try to but this transaction A try to add up 10 items to this person, so you should, after add 10, you should this person should have 20 items, and also this transaction B also want to add 10 items to the person A. So when it does it, actually what you want is that you want a person A, maybe your person, randomly person should have 30 items after those two transactions finish work, right? But in some of the cases, if the person B just update based on the old data, like the 10 items, the result will still be 20. So actually the transaction B lost its update. So it's more like something happened in the risk condition, right? So we can use some mechanism like something similar to optimistic lock to resolve this lost update. So you can further introduce one column, maybe called version column, in your table. So in maybe when you send query to your database, you will use select statement, both of them, you use select statement to select the result like 10. And when you try to update the value based on this old value, so you try to update when you're trying to send another update query, like update the this item to 20 because you want to add 10 based on the old data. You will try to do something like use the where clause, where the version maybe only updated, where the version maybe equals to the version that you read. So here, when you read 10, you got the version of version 1. You only update it where the version still equals to version 1. And with this update, with this conditional updates, um, you can achieve something similar to optimistic lock, because when you update it, this data record will have a third version of version 2. So in your transaction B, when you try to update, also when you try to update 20, uh, where version maybe equals to version 1, it will fail because it will find that the version has already been changed to version 2. So it will fail, and maybe in your program, you will write something like, I will use a while loop or something like that in your program to select again, and get the new data 20 with version 2, with the version number of version 2, and then you can try to update to 30 where version equals to version 2, like this. You can do something like this to resolve the lost update. So it's kind of similar to like compare and set, right? You only set it where the expected value is equal to the current value, right? It's kind of like this compare and set. So it's called, you can call it to be a optimistic lock to resolve the last update. Or other thing is that you can just maybe, but whether we can use a lock to resolve this, let me think. So if they are happens in one transaction, then I think you can use the lock to resolve it. So the lock is that in the database, you will have two types of lock. One is called share lock, and one is called exclusive lock. So this is called optimistic lock, right? You're not actually adding lock, you just update, have a conditional update, like only update when the version is equal to the version that expected. But there's actually real lock in the database that's called share lock and exclusive lock. Like when you select some data for share using something like this, then that means you are adding a share lock. Share lock is more like a read lock. So what does read lock means is that also, as the name infers, this lock can be shared. Like it will, if other transactions try to read the same rows when you add the share lock, then that is allowed. So you will allow multiple transaction to read on same row, like same record, but you will block the write operation. So that means when I try to read something, I can just add a share log. So in this case, I won't block other read operations. So that means other transaction can also read it at the same time, but I will block all the write operations. So when I add the share log, it's saying that, hey, I'm reading on those columns, please, other people should not update it or write it. So it's called a share log. But because I'm just I won't modify it, so I just add some read log to allow other transactions to also read on this part. Because if you there is no reason, it's not reasonable that if you only read it and you do not allow other people to read it at the same time, right? It won't harm. Like both of you just read the same column, just to prevent other people to write to it, just prevent other people to modify it. So this is called a share log. And there's also one thing called exclusive log. That is, you can write something like select blah 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 for update. So this will gives you a exclusive log. So you can try, I think this for share statement is not, this syntax is not allowed in the Oracle lifecycle, but I think this for updates is allowed. Maybe we can try it for updates. This sorry, this session has been, this session has expired. Let me, sorry, let me log in again. Sorry, I kind of forgot my password. All right. Okay, now I go back. Okay. So we can try to write something like, maybe just this, run it. Invalid statement, but what if for share? Oh, I didn't include it. About for update. I remember that Oracle lifecycle does not support the for share, but yeah, it support the for updates. Like when you use, but if you use the MySQL, you can use the for share. That is to add the share log. But like here, if you use the for update, it will add exclusive log to your select rows. So what is exclusive log means? That is, that means you are trying to update or modify this column, this rows. So that means it will block all the other transactions, read and write operations, because you are updating it, you are modifying the value. So you should not let other transaction to read it for the data integrity reason, right? Like if you're trying to modify it and other transactions still reading on it and working on it, maybe they will working on some data that will be modified very soon. So it's not a good idea. So you just add the exclusive log to this rows. So these are different type of logs in the database. And, yep, I think that will be all the content that I want to cover for today. And any questions for today's session? So if no other questions, then you can feel free to leave for today's meeting, and we will meet tomorrow at the same time.